Okay, let's talk about how to make bar charts and histograms using ggplot. Okay. So the important things to note are that we still run ggplot data in my data frame, and we specify the mapping or default values for the x variable and the y variable. Then we're going to use gmbar or gmhistogram to construct bar charts or histograms. Other options that I won't focus on as much still do apply. So it's good to make sure you understand and review what those are. Okay, so let's go through basic bar chart. Here's the pseudocode. We're going to again specify my data. You specify your data frame so that ggplot knows what we're working with. You can specify the x-axis. At a minimal, you'll want to specify the x variable is my x variable of interest in your data frame. And then you'll use gmbar and pass options for constructing your bar chart accordingly. All right, so let's just jump into an example. I'm going to load the data set from here. I have a bunch of stuff in here, but here I have class.data is the social media data set we've been working with. And I would need to install the ggplot2 package if I haven't already, and need to load it. Once you've installed it once, you just need to load it. And again, it's always good to refresh your memory if it's been a while since you've used ggplot on the basic help file. So it's just going to go through the main things that I've just mentioned. First thing is to specify your data and your mapping. And then you use GM points, what we've focused on before for scatter plots. Now we're going to look at GM bar. So let's jump in. Here I'm going to construct a bar chart, and on the x-axis I have gender. So the default is just going to give you this. So I have 20, looks like about 23 females and 12 males, and so it just gives me a simple bar chart with females and males. And of course, as we recall, the labs function, should reread the help file for that, but it talks about how to specify titles and captions, adding those to a ggplot. So for example, rerunning the same code, but don't forget to add this plus sign again. Now I'm going to add this, use this labs function. Title is, here's my title. I'm going to specify this for my X label and specify this for my Y label and add a subtitle that says that. There we go. Somewhere I had an error. Oh, I ran ggplot twice. And so if you ran this code, ggplot, I've specified my data frame, my x variable, gm bar, and then the basic bars still, and now I've added this title using the labs function, and this caption. So nothing new here for the labs. Now let's look at the help file for gm bar. So what changed below, let's look at what will change the border color and inside color. And so if you read GM bar very carefully, you could find out exactly why these added options work and how they work. So again, let's run through this code, and I'll have you read these files carefully to figure out exactly how I figured this out myself. So ggplot, I'm doing mapping, I'm specifying my x variable as gender, so gender is going to go on the x-axis. I'm running gm bar, but now I'm specifying color is black and fill is equal to blue red. So if you read the help file, you'll figure out what that is doing. Black, and then fill is blue red. So color is the outside lines of the plot. I'll just tell you what the answer is. The outside lines, when you draw the bars, you draw a line around the outside of the bars. That means draw black lines, and then the inside should be blue and red. And I've added coordinate flip. So let's just go ahead and run this code, then discuss exactly what happened. So here, black, that gave us black lines around the outside of the boxes. Coordinate flip, if you read the help file for coordinate flip, you'll see that it now has the gender is on the y-axis and counts are on the x-axis. So now we have a horizontal bar chart. In labs title, I just added this title so that we can read it and see what's going on here. And the subtitle, notice this is still inside the function labs. Subtitle, I added coordinate flip to get horizontal bars. And so that just put those words up there. Stack bar chart. So suppose we have two factors that we're interested in. So maybe more than just a bar chart across different levels of gender. Let's look at how we would do that. So here's the pseudocode. ggplot, data is my data frame again. And then my aesthetic, my mapping is I'm going to need to specify two variables. And in this case, I've specified fill is the second x variable. And the first x is the x variable on the x-axis. So this will say what colors. The colors should be determined by the second variable of interest. And the axis will list the first variable of interest. And then the other thing to consider is GM bar. I'm going to specify different positions for different bar charts when I have two factors. So it is going to basically for us be fill or stacked. So you can read the help of GM bar files for more details. And I've given you a hint. If you scroll through it, see the details all the way down here. And it will tell you here are all the different options for the details that are common for GM bar. So like position equals stacked, you would specify position equals dodged, position equals fill would be the common ones. All right, let's see what position equals stack does. So here, I've specified my class data. I specified that on the x-axis will be gender, and then I will fill by Pinterest. So indeed, on the x-axis is gender. The filling color is determined by Pinterest. And so here you can see, because I've specified position equals stack next, that I've stacked these bars on top of each other. So here's all of the female counts. So there are 13 females that had a Pinterest account. The rest were females that did not have a Pinterest account. This box here represents males that did not have a Pinterest account, and this little blue box represents males that did have a Pinterest account. I might not want to do stacked bar plots, and in which case I would just change position equals stack to position equals dodge. Perhaps a more common bar plot. And so here we have the same thing, except for the position equals dodge told R to put bars next to each other rather than stack them on top of each other. So we still have 10 females that did not have Pinterest accounts, and now we can see that there were more males that had, there were more among females. We can compare Pinterest versus non-Pinterest a little more easily, and we can compare among males the difference between Pinterest versus non-Pinterest users. Okay. Now we might want to put Pinterest on the x-axis here, and so we might want to flip where Pinterest and gender is. So how would I do that? And again, it's just a matter of specifying in this option here, x is equal to Pinterest, filled by gender. And then everything else is the same. And we get a display of the same data, but now we can see for Pinterest, for non-Pinterest users, it was 50-50 split between males and females. And then for Pinterest users, there were more females than males. And I want to mention there's other plotting positions can be specified by adding the position equals value. So we just looked at dodge and fill and stack. There are many others out there. You would read the GeoMBar help file for more details. All right, let's move on to histograms. So the pseudocode here is this, ggplot. Again, I'm going to specify my data. Initially, we'll talk about specifying x as my x variable, and I probably need to tell ggplot on the y-axis, should this be scaled, not scaled, and so on. We might specify this function in the second layer, depending on what we want to do. But either way, we have x, and we can specify what should go on the y-axis or leave that to be specified later. And then we have geom histogram, and we have our options that we pass to construct different types of histograms. And then we can add a density curve by geom density. And I'll talk about in a moment how to specify different density curves. This is a specific type of density curve that is popular. Okay. So let's just jump into an example. Here I'm again specifying my data set as my class data, and I'm going to want to specify on the x-axis should go introvert, and if I just use the default geom histogram, you'll see that it doesn't have a very nice default value for the number of bins. So you would never present this histogram in practice. What happens using bins is equal to 30 as the default rather than some other commonly accepted methods for specifying a default. So for whatever reasons, it automatically always uses a default of 30 bins. So we're going to want to change that if we have a smaller sample size. So if you read the help file for geom histogram, you'll see that the primary options are bin width and bins. So I'll just show you how to use those. So same arguments in this first line. Now I'm going to say use 10 bins. And I'm going to change the color just so we ease into specifying different options to blue. And so now here I have 10 bins indeed. You can count them 1, 2. This is still a bin even though there were no counts here. 3, 4, up through 10. I could also specify bin width instead of the number of bins. In this case, I specified a bin width of 1.5, and we get this histogram. If we wanted to add a density, let's look at the help file for geom density. And so this is using the kernel density estimator. And so this is a somewhat advanced method for approximating a histogram called kernel density estimation. The key parameters are going to be bandwidth that we'll focus on. And there are some other parameters that we won't touch on. So the key parameter is bin width. There'd be potentially some reasons to not use, to change the default from the kernel, but I don't think we'll get to them in this class. ggplot, let's jump through the example. Now I'm being careful to specify y is equal to ... density. If you read the help file for ggplot, you'll see why, especially if you read help for geom density. See why we need to specify y is equal to density. So if you leave this argument off, on the y-axis you have counts, and then when you go to specify a kernel density estimate, that's a density estimate, not an estimate of counts. And so the y-axis for histogram and density would not be the same if you leave off this y is equal to density specification. So again, I'm just going to specify in my histogram that the bin width should be 1.5, and I'm going to use blue bins just as I did above. The only thing I'm adding is, of course, I have to add this plus sign, but I'm also adding now geom density. Color is red, line width is 2, and line type is 2. And so here it estimated the density of this data using kernel density estimation. options that you could specify here. Bandwidth is equal to 0.5. So there's a default bandwidth which talks about how much this line should be smoothed. So let's just rerun this code just to look at it. You'll see here the bandwidth is smaller, which means it's a more jagged curve. If the bandwidth is larger, it'll be a smoother curve. And so you can play around with different bandwidths if you don't want to use the default. Okay, adding other curves. So just some pseudocode. I'm going to add plus geom. So I'm going to add this geom function. And I'm giving you this one because this can use any function. This is akin to or similar to the curve function in R when we would use in the base plotting package where we would use curve and then add is equal to true. And curve could input any function. That's what this is going to do too. Geom function. The pseudocode says fun equals specify your function. And then args, your function should have, there should be a first value of inputs, x's, that needs to be specified, but you might have other x's, some other arguments in your function that you could pass through using this guy, args is list function argument 1 equals value 1. So here's how you would specify default values in your function. And then after you specified values for your function, then other arguments can be passed through geom functions set to change the line type, the line width, the color, and so on. Okay, so now I'm going to leave off. Let's run some sample code first. So notice here I didn't specify in the first layer y is equal to density as I've been doing so that R doesn't get confused because that y argument shouldn't be the same all the way through. Only when I construct my histogram do I need this y is equal to ... density argument. So I'll pass it through here, geom histogram y is equal to density. So this tells if you leave this part off, then you'll have counts on the y-axis, and your density curves won't match your counts on the y-axis. And so I'm going to, again, do bin width is 1.5, and fill is equal to blue for the default. And now here I'm going to add my density function, just as I did before. So this is the same line of code as above. So let's put that on there. And now what am I doing? I'm going to say geom function, and I have function as dnorm. So if you remember, dnorm is a built-in function that talks about the density, that inputs x and returns the density of x. And it has arguments that you can specify, like the mean and the standard deviation. So here in this case, I'm going to say use the function dnorm and specify arguments mean is equal to 4 and standard deviation equals 2 in the dnorm function. So now this will return a normal density where the mean is 4 and standard deviation is 2. If you left this off, it would compute a standard normal density estimate. So it would use default mean is 0 and default standard deviation of 1. All right, so, and then this is still within the geom function. I'm going to just change my line type to 2 and my line width to 2. And here is my normal density curve added to the top. The line type 2, line width 2. I didn't specify a color, so it's going to use black. Okay, so again, everything that we talked about is focusing on bar charts and histograms, and we use ggplot for constructing histograms and bar charts by adding geombar or geomhist. And we also added how to add a custom curve to a histogram using this last guy here, a geom function, which should be quite flexible, so you can use this in other ways. It doesn't have to be the dnorm function. It could even be a function that you create.